Hey everyone, you ever type something into an AI and just wonder what's actually going on in there? It feels like magic, right? Well, today we're going to pull back the curtain. We're going on a journey deep inside a large language model to see exactly how it works.
Okay, so you type your prompt, you hit enter, and then what? How does this machine, which only gets ones and zeros, start to understand the meaning, the vibe, the whole point of your words? That's the big question we're tackling today.
So our journey starts with what's basically a translation problem. See, the AI doesn't speak English, it speaks math. So the very first thing it has to do is break our human language down into little pieces it can actually work with.
To make this all super clear, we're going to follow one simple little prompt from start to finish. I love AI. Yep, those 3 words are going to be our guide through this whole amazing process.
The first thing the model does is chop up that sentence. In this case, it's pretty simple, right? I, love, and AI become their own little units. You can think of it like a chef prepping ingredients before they start cooking. These little pieces have a name. They're called tokens.
And this whole process is called tokenization. But here's the really clever part. It's not always just about splitting words. It can break words down into smaller subwords like un or able. This is a super smart trick that lets the model understand and even use new or rare words it's never officially seen before. It just builds them from the parts it already knows.
Okay, so we've got our tokens, but they're still just, well, they're just text. The next step is to translate these tokens into the AI's native language, which is numbers. But these can't be just any random numbers. They have to capture the meaning of the words. Let's see how that happens. This is where something called embeddings comes in. Every single token gets mapped to a long list of numbers. It's called a vector. The best way to picture this is to imagine a giant multidimensional map of meaning. On this map, words with similar meanings are located super close to each other, kind of like friendly neighbors in a huge city. And this is something that just makes sense to us, right? We know that doctor and nurse are related ideas, and we know that doctor and planet are not. The AI gets this, but it does it with math. The number vectors for doctor and nurse are really close together in its meaning space, while the vector for planet is way off in a different zip code. This is how the AI starts to get semantics. All right, so now we have our tokens and they have numerical meaning. But you and I know that language is way more than just a bag of words. Context is everything. So how does the model figure out which words are the most important for understanding the whole sentence? This, my friends, is where the real breakthrough happens.
I mean, just look at this sentence. If you only read the words recommend and product, you'd get the completely wrong idea. But that one tiny little word not completely flips the entire meaning on its head. For an AI to truly understand you, it has to have a way to know that not is critically attached to recommend.
And it does this with an amazing mechanism called self-attention. It lets the model look at all the tokens in the sentence at the same time and decide how relevant each one is to every other one. Seriously, it's like a spotlight operator in a theater, making sure to shine the light on the key actors who are driving the story forward. This is why attention is such a game changer. It's how the model understands negation. It's how it connects a person mentioned at the very beginning of a long paragraph to what they do at the very end. It even uses something called multi-head attention, which is kind of like having a whole crew of spotlight operators, where each one is looking for a different kind of connection. One for grammar, one for meaning. You get the idea. It's incredibly powerful. So we've followed our prompt through tokenization, embedding, and these really complex layers of attention. The AI now has this rich, deep, contextual understanding of what we asked. So how does it use all that to actually write a reply? Well, it all comes down to a prediction game. After processing your prompt, the model looks at its vast training data and asks, okay, based on all this context, what word is statistically most likely to come next? It doesn't write a whole sentence at once. It predicts one token, adds it to the sequence, and then does the whole thing over again, building the response one tiny piece at a time. Now, how does it choose the perfect word every time? Well, it has a few different playbooks. There's a greedy approach that just grabs the single most likely token. It's fast, but can be a little boring and repetitive. Then there are other methods, like sampling, that introduce a bit of controlled randomness. That's often what creates that more diverse, creative, and natural-sounding language we see from the best AIs today.
So there you have it. We've gone from a simple text prompt all the way to a fully generated response. Let's do a quick recap of the entire process just to see how all these incredible pieces fit together.
It's really a four-stage journey. First, tokenization chops our text into those manageable pieces. Second, embedding turns those pieces into numbers that actually capture meaning. Third, the attention model goes to work, building that deep understanding of context. And finally, the model starts predicting a sequence of new tokens to create the final response. And so our simple little prompt, "I love AI," after going through this whole whirlwind tour, might get completed like this. The model understood the positive sentiment of love, it knows the concept of AI, and it predicts a totally plausible and relevant continuation, one token at a time. From text to tokens, tokens to meaning, and that meaning to a whole new sentence, it's not really magic anymore, is it? It's a clear, fascinating, logical process. And once you understand how it works, you really start to see just how powerful this technology is and how limitless its potential might be. Which leaves us with just one question. What should we ask it to do next?